Okay, so you're watching this video because you have just run this function that I wrote for you, in which we created a new object called county pills population. We started with the county pills per year table. That was the information that contained our average number of pills per year for each county. And we interjoined it to the county population table. So just briefly, I want to show you the tables that we're talking about here. So here's county pills per year. It has 3 columns describing the geography. So each row is a county, and then the first row is the unique identifier for the county, the name of the county, and the state in which the county's in. And then the 4th column is the average number of opioids sent per year to that county. So this first row here is the average number of pills sent to Watauga, Alabama. Then we also have this county population table. So you'll notice it has the same 3 columns here containing the same information. So county FIPS, Byer County, and Byer State describe the geography. So this first row again is for Watauga, Alabama. But instead of pills, what we have in this table is the population. So the population of Watauga is 52612. So the join process put these 2 tables together. So you'll notice that the table county pills per year and county population both have 4 columns. When we put this together, the new one, which we're calling county pills population, has 5 columns. So let's take a look at that. So this is our newly joined table. Again, what we have is the geography for each county. Each row is still a county. So we have the county FIPS, the unique identifier, the Byer County name, and the state name. And then, instead of just having average pills per year or population, we have matched those up into a single table. So how do we know that how did the join process know to put this population value with this average pills per year value and stick that with Watauga? So the join process creates a new table, and what it did was it looked for the matches where Watauga, Alabama, where this information was the same in this table as it was in this table. Because it found a match, it knew to put them together. And it's why we ended up with these 2 column values next to each other in this table. So every time, the join process goes through every single row and looks for matches in the other table. So every time it finds a match, as it did, say, with Baldwin, Alabama in this table, and Baldwin, Alabama in this table, it knows to put the value for that county for pills from the first table and the value from population in the second table together. If it doesn't find a match between, say, there's if Baldwin, Alabama existed in this table in the average pills table, but not in county population, the interjoin process just would leave it out of the new table that we're creating. That is why, by the way, and in subsequent videos, we'll see why these 3 tables have different numbers of rows. So our original population has 3143 rows. Our original pills has 3130 rows. So we can see that each row is a county, basically. And there's different numbers of counties in each table. The joined table has fewer rows even than either of these. So it has 3,036. Why? Well, we'll see that later, but the reason is that there are some counties that are in our pills table that are not in our population table. And there are some counties that are in our population table that are not in our pills table. And when we do the process of putting them together using an inner join, those counties that don't have corresponding matches are simply left out. So we'll see that in more detail below. But for now, keep working down the lab.